So here is another exercise for the calculated column. So in this calculated column we will be using a conditional formatting, like conditional functions like if and switch, to add calculated columns to a Power BI data model. So I have already downloaded this file, as you can see here. Okay, so let's go with step by step from here. So first thing, open the tallest building conditional formatting function pbix file in the folder that's shown above and switch to the table view of the building. Add a calculated column called has basement, which tests if the value of the floor below ground column equal to 0. If so, the formula should return no, otherwise it should return yes. So it's basically telling us like if we go here and in the building table, if the floor above ground, this one, so if the floor above ground is greater than 0, then no, let me check. It is telling add a calculated column has a basement, which tells us floor below ground. So we need to add one calculated column. So we will add column and we will write it as has basement. We will write short form, and here we will go and we will use if function. If, and we will type the logical, we will use the floor below ground. If floor below ground is greater than 0, then return yes, else return no. So after adding this, if you can see the floor below ground where there is 0, no is appearing, and where there is 6 7 1 2 3 4 5, then yes is appearing here. So our formula is correct right now, and we will go in the problem statement and we will create a matrix same as this to check if we are getting accurate values or not. So we will go here, we will add one column and we will add, let's say has basement here, which is giving us the two values. One is this yes, no, and we will add count of building IDs here. So building IDs into the values and the count. So we here in our file we are getting 93 values, and in the problem statement there is also 93. So till here we are okay, and our solution is working. Now we need to add one more calculated column here called century, which uses if function and to show the century in which the building was open. So okay, we need to make same like another column with the same strategy like the 20th century or 21st century. So it's showing that a building which opened before 2001, it belongs to 20th century, and after 2001 it belongs to 21st century. So we will add one more column here, new column. We will add century, column name century, and we will use same if. We will take the year open column, this one, building year open is greater than, let's say we can take is less than 2001, less than and equal to 2001, then it should give us 20th century. And if the result is false, then it should give us 21st century. So now it's giving us this. Now we will check this answer also in our matrix. So I will take this and copy this, and I will take the century column here, 21st century and 20th century. And as you can see that here they are taking average of total floors and average of height. So we will also take the same thing, average floor. So we will take this as average, and the next column was okay, so they are taking this one, height m, so we will be taking average. And next column was this average of total floors. So if we check these values are matching with our site values or not. So like in 20th century we have 86.50 total floors, average of total floors, and average of total height is 358.76, 86.50. Overall it's 90.09 and 416.05. Yes, till now it's matching, everything is working. Now we have to create one more calculated column called size, which will use the switch function to assign each building to a category according to their. So we will use the switch function where we will assign these values, like if the height of the building is less than 400, then it should be tiny or something. So let's create one more calculated column here. We will name it as size. We will use switch function where we will take the height m column, where and yeah, so sorry guys, this calculator would not be here. So yeah, so we will take switch, and then we will take height of the floor, building height m, where the first value was 400. If you can see, like less than 400, so less than 400, so we will take it as less than 400. Then it should return us tiny. Okay, and next value is 400 to less than 500, so we will take it as building height equal to 400 and building height less than 500. We will name it as small. Next one is height 500 to 600, greater than equal to, we can use greater than equal to here also, so that it should not get confused. so greater than equal to 500, and height is less than 600, we will name it as medium. Height equal to greater than equal to 600 to 700, less than 700, we will name it as big. And then whatever is 700, like equal to 700 and more than 700, it will be massive, so we will write it as building height equal to 700 equal to greater than equal to 700 would be massive. Yep. So we have another column called size, and we have written all the decks whatever is necessary here. To check this if we are getting the accurate values or not, we will use this chart, the count of building chart. It's a bar chart, a column chart. So what we will do, we will drag one column chart from here, okay, and we will take the size column here below, and we will take another two columns, count of building ID and average of total floors. So building IDs as a count of building IDs and average of total floors. So we will take this as average. So now for tiny, if you can see, the count of building is I think 50, and the average total floor is around 75 or something. So are we getting? Yes. For massive it's above 150, for massive it's above 150. So we are getting an accurate value for all these functions that we have. Okay, so till now we are getting everything accurate. Every calculated column that we have added is now giving us the accurate values. Now here we have another problem situation where we will create a calculated column called location, which test if coordinate column is blank. If so, the formula should return unknown, otherwise it should return the value of coordinate column. Okay, so if we go in our data and if we see coordinate column here, we can see, okay, right now we can see that there are some blanks, 1 2 3. So we will be adding one more calculated column. So this data doesn't look very much accurate and very much clean, so that's why we need to clean this. So let's say we will name it as new coordinate. Now what we want if the value here is true, then it should give us the same value. But if it isn't true here, like if the value is not present here, anything is blank, it should return us unknown. What do you call it? Unknown. It should give us unknown text. Okay. And so here we will use is blank function. So the situation is, if in this coordinate column, if something is blank, then it should give us unknown. What it should give, it should give us unknown location. If nothing, then it should give us the accurate value whatever is present here. So we will use this is blank if is blank, which is coordinates from here, then it should return us a value called unknown location, else it should return us coordinates only. If I click here, yes, if you can see, everything is same, but where there is blank, then it's giving us unknown location. If I just filter out unknown location only here and I press OK, you can see the coordinates here are all blank. So yeah, that's it for this exercises, guys. Thank you for watching. Have a nice day.